Hello, students. Welcome back. I would like to go over this CNC program with you that goes along with this module. So I'm going to pull that up right now. So here is the program. It is a CAN drilling cycle. So that's what G81 means. So we're actually drilling some holes. If you look at the geometry we created for this module, it has 4 holes. And we're going to drill those 4 holes using this program. Okay. Now, as you notice here, let me pull this down just a little bit here. The percent sign right here means the beginning of a CNC program. That's what it means. That's the beginning. And notice that this number right here, this is just the file name. It's the letter O. It always has the letter O followed by the file name. In this case, the file name is a numbers 10075. And what you see in the parentheses is a comment statement. Okay, so it has no impact, on the program except for helping the reader of the program interpret what it means. So this is a comment statement that says this is a drilling cycle. And the N10 is a sequence number, and we're going to use this case is tool number 16. So the tool number 16 and the turret uh, is a 1/2 inch diameter drill. Okay, this is a description of the tool right here. And it also, M06 means that you're going to actually, uh, you're performing a tool change. So what tool are you changing to? You're changing to tool number 16. So M06 just means a tool change. N20, this is the address or the sequence number. G90 is absolute programming. That means every position or tool location or the tool path is in reference to X0, Y0, Z0. Okay? So everything is absolute coordinates. Now, the G54 here indicates the coordinate system or the work system here, 1. I got some notes down here to help you with this program. And it's going to go rapid. G00 means to go rapid, where G01 means to go linear, and G02 means to circular, and so forth. All right, so G00 means to go rapid to this location right here. All right, to that location. And it wouldn't hurt here to actually put a Z height above the workpiece, and we'll get back to that shortly. We also have the RPM of the spindle as 1,450 revolutions per minute for the spindle, and M03 means that you're turning the spindle on clockwise. Okay. Now, every tool has a different length. One more time, every tool has a different length. So each tool must have a tool length offset based on the length of the tool. So the reason is H16 on the actual CNC machine where you input the tool length offsets, we're going to put in the length for tool number 16. And we're going to go 1 inch above the workpiece. That's what Z1 means. Okay, if you come down here, Z1 means you're 1 inch above the workpiece. Z0 is when the tip of the tool is touching the top of the workpiece. So a negative Z value would indicate that you're actually cutting into the material. Any positive Z value means that you're above that work plane. You're above the Z0 work plane. Okay? And also, we're going to turn on the coolant. That's what M08 means. You turn on the coolant because you want to keep the tool cool, obviously. You don't want to wear out the tool If you're not using coolant, you're going to wear out. You're going to make the tool very dull quickly. So you want to make sure you have the coolant on. The coolant also washes away the metal chips so that the metal chips does not scar the workpiece. So sometimes, certain workpieces, the metal chips will scratch the workpiece. So again, you're trying to keep the tool cool, which extends the life of the tool, and you're washing away the chips, which actually gives the part a better surface finish. Okay. Now, going to the next line, G81 means that we're going to be doing a drill cycle. We're going to drill the 4 holes. Again, if you look at the picture, the PNG file, or the PDF, you will see that there are 4 holes. And those are the holes we're going to drill. And we're going to go down a depth of 0.375. We're going in the negative Z direction. Right here. It's a negative Z direction. You're going to go all the way down until you go 3/8 of an inch into the workpiece. And then you're going to come up 0.1 above the hole. That's the retract plane, if you will, okay? We'll call it a retract height of 0.1, and it's 9 inches per minute, okay? The feed rate is 9 inches per minute. Then it goes to the next X value. Now, the reason why they don't have Y here, because they're still using the value of Y previously. So the Y of negative 0.5 is still active, and this is our X value. Then we change, then the X value stays the same, and we go to a new Y value. And then again, these are just your coordinates. These are the locations or the center points of your holes. And then the G80 right here cancels the G81. The G80 cancels the drilling cycle, and it tells it to go rapid 1 inch above the workpiece, okay? And then you're going to obviously cut the coolant off. So that's what it means by M09. It cuts off the coolant. You don't need the coolant now because the tool is basically cutting air at this point, okay? And then G53 is the code that indicates that you're going to cancel. Well, it moves the machine 0 in the Z-axis. That's what G53 means. And it cancels the tool length offset. G49 cancels the tool length offset. I'm sorry, I know you can't see the program. G49 cancels your tool length offset. And then you got a value of Z0, which means you're right at the top of the workpiece, but you're not on the workpiece. You're actually off the workpiece. And M05 is going to be the end of the program. Stop the spindle. Well, actually, M05 stops the spindle, and then M30 means the end of program. The M is a miscellaneous code. Okay, remember you have G codes and you have M codes, which are used for, again, to control the position and the movement of the tool. But you also have a T code, which means the tool number. S is a spindle speed in RPM, and then you have some other codes like F is the feed rate, moving in inches per minute or millimeters based on what units of measure you use. It could be millimeters, it could be inches per minute. And then you have some other letters that have some special meaning that you'll learn about later. Anyway, so that's the program. All right. And what I'm going to do to make life easier for me here is I'm going to copy so I don't have to retype it. I'm going to copy this program. All right. I'm going to go over here and I'm going to pull up NC Viewer. Sorry. NC Viewer right here. pull up this, and we want to start a new file. So anytime you start a new file, click on this plus sign here. And I'm just going to do, right click and paste. There's my code right there. I just copied it and pasted it in there. But you would have to type this in here line by line if you're not able to copy like I just did. Okay, and we can come down here and type in plot, or click on, I'm sorry, not type in plot, but click on plot, and you can see there's going to be a hole here, one here, one here, and one here. And you can simply run this by hitting the, well, first of all, you have to click on the first line. Position your cursor right here. The tool is going to show up, and it drills the holes. One more time. Click here at line 1 with your cursor. See how I position the cursor on line 1. The tool appears, and it drills the 4 holes. Again, this is hole 1, hole 2, hole 3, and hole 4. All right, that completes this program. It's going to be a part of that module. I'm not going to create the geometry because at this point it's assumed that you know how to use either Autodesk Inventor or you know how to use Fusion 360. And I have shown you how to do that on a couple of the modules, the earlier modules of this course. Thank you very much and have a good day.